NASA's X-59 supersonic aircraft just moved under its power for the first time, taking us one step closer to a future where flying faster than sound won't shake the ground. This isn't science fiction, it's a major shift in aviation. For decades, sonic booms made overland supersonic flight impossible. But now, the X-59 may rewrite those rules. In this video, we'll explore how this jet works, why the recent taxi tests matter, and what this could mean for air travel in the next few years. What makes the X-59 so revolutionary isn't just its speed, it's how quietly it travels beyond sound. Designed by NASA and Lockheed Martin, the jet stretches nearly 100 feet long with a sleek, pointed nose that's longer than most business jets. Its unique shape diffuses shockwaves, dramatically reducing the sonic boom. Instead of a loud crack, the X-59 produces a soft, sonic thump, around 75 perceived decibels (EPNDB), similar to a car door closing. To make this shape possible, the pilot doesn't use a traditional windshield. Instead, they rely on NASA's Advanced External Vision System, XVS, which uses high-resolution monitors and front-facing cameras to simulate a forward view. That design keeps the nose long and aerodynamically smooth, essential to reducing shockwave strength. The aircraft is expected to cruise at Mach 1.4, about 925 miles per hour, at 55,000 feet, much higher and faster than standard commercial jets. But it's not built for passengers. It's a research platform to gather flight data and community feedback. If people on the ground barely notice the aircraft passing overhead, NASA can make a powerful case for changing U.S. and global aviation regulations that have blocked supersonic travel over land since 1973. On July 10, 2025, the X-59 underwent its first taxi test at Lockheed Martin's Skunk Works facility in Palmdale, California. This test marked the first time the aircraft moved using its own engine power, an essential milestone before any flight takes place. The test focused on verifying basic systems like steering, braking, and overall ground handling at low speeds. NASA test pilot Nils Larsen was in the cockpit, slowly guiding the jet along the runway while engineers monitored every response from onboard systems. Though the test reached only low taxi speeds, it confirmed that the engine, hydraulics, and brakes are functioning as expected under real-world conditions. Next up will be high-speed taxi tests, where the aircraft will accelerate close to takeoff speed without leaving the ground. These trials are designed to identify any unexpected vibrations or control issues before it lifts off. With each stage, the team gains more confidence in the aircraft's readiness for flight. These tests are the bridge between theory and reality. They validate thousands of design hours, simulations, and safety checks. Without them, there's no way to ensure the aircraft can safely take off, fly, or deliver the data needed to prove its low-boom concept in action. Why does all this matter? Because if NASA proves that supersonic flights can be quiet enough, regulators may finally allow commercial supersonic travel over land, something banned in the US for over 50 years due to the disruptive noise of sonic booms. Once flight tests are complete, NASA will conduct community response studies by flying the X-59 over select US cities and collecting feedback from residents. These responses, along with acoustic measurements, will be used to develop new noise regulations that could reshape global aviation policy. The long-term goal? Enable a new generation of quiet, fast airliners. That means a flight from Los Angeles to New York in under 3 hours, without disturbing people on the ground. While the X X-59 itself won't carry passengers. Its technology and research will pave the way for future commercial designs to be both fast and socially acceptable. NASA expects to complete initial flight testing by late 2025, with community overflights starting in 2026. The data gathered will then be shared with the FAA and international bodies like ICAO to help inform next-generation noise standards. If successful, this could lead to a world where quiet supersonic travel becomes not just possible, but practical. The X-59 isn't just a sleep jet. It's a signal that the future of air travel is changing. If successful, this aircraft could erase the barriers that have held back supersonic flights for decades. Imagine cutting long flights in half without disturbing a single neighborhood below. NASA's recent taxi test is just the beginning, but it proves we're getting closer to quieter, faster skies. So next time you hear a plane overhead, you might not hear it at all. Thanks for watching. Don't forget to stay curious, and we'll see you in the next one.